In this video, I'll be providing an overview of the vacuum system used in the Porsche 944. This content will largely center on a late model from 1988 that features the Venturi delete update, but I'll also call out some differences between the early and late versions as they arise. Vacuum leaks can present a number of different symptoms depending upon the location and the severity of the leak, but some common items include high idle or running lean, rough idle or stalling, hesitation or misfire when accelerating, an idle mixture that defies any adjustments, hissing or sucking sounds from the engine bay, poor fuel economy and emissions, and disconnected, loose, cracked hoses or broken fittings. Vacuum leaks can generally be identified using a smoke machine or through visual inspection of the components on the car. I figured it would be a good idea to start with an overview of engine vacuum, the different components, their functionality, and the basic routing of the system. As you first approach the vacuum hose routing, it can be a little bit confusing because some of the lines are hidden away under the intake manifold, but once you identify the different pieces, where they're located, and what they look like, it's pretty straightforward to get set up and replace the lines if you need to do so. The heart of the vacuum system is the engine itself. Internal combustion engines are basically like an air pump, and as each piston is pulled down into its cylinder by the crankshaft, it creates space in the cylinder to draw in air from the intake manifold, and this happens repetitively for each intake stroke on each of the cylinders, and that creates a vacuum pulled through the system. And the vacuum pressure can then be used to power various components or accessories on the car. So in situations where there's a vacuum leak or things are disconnected, unmetered air is now entering the system, and as a result, engine performance won't be optimized, and depending on the severity of it, the car may not run at all. So with that in mind, let's take a closer look at each of those components. Overall engine vacuum is harnessed here in the intake manifold, and there are a number of larger and smaller connections branching out to harness that power. For the larger items, it consists of the air oil separator, the brake booster, and the idle control valve. And on the smaller items, those split off to some control valves for the fuel vapor management and a thermo switch to activate those. And then the fuel management, so fuel pressure damper and the fuel pressure regulator have a vacuum supply. And the final piece on the smaller lines is the HVAC system, so there's a vacuum reservoir, the heater control valve, and some lines going inside the cockpit to manage the ventilation system inside. Here's a closer look at the connection point for the air oil separator, and the line wraps around underneath to the top of the filter for that unit, and then across to the J-boot, and there's a bypass for when the throttle body is closed, so that has a constant supply of air to that filter, and the air oil separator acts to catch some of the oil residues and vapors that are flowing through the system so that they're not recycled into the cylinders, and that provides a little bit cleaner operation. Next to the air oil separator is the brake booster, and the brake booster has a check valve and a vacuum line that runs to the front of the intake manifold. Inside the booster is a diaphragm and two chambers. On the pedal side, it's at atmospheric pressure, and on this side, it's at vacuum pressure. And when you press on the pedal, that vacuum attempts to draw the master cylinder forward and provides assisted braking, makes it easier. So if the booster has failed or if this line is cracked or disconnected, braking will be very, very hard to stop the car. And you can also test it with the car turned off by pumping the brake pedal a few times. Inside, it should firm up, and you can tell that it's holding pressure. And when you start the car, the pedal will slowly sink in a little bit, and we know that vacuum is applied to the system and it's working correctly. There are a couple different check valves that are used in these cars. So this one is an L-shaped, it comes out and down, and there's another one that is a T-shaped that has another little connector here that routes back to the heating system. On this car, they moved it over to behind the fuel pressure regulator, and we'll talk about those differences a little bit more in a second. At the front of the J-boot here, we have the larger connector for the idle control valve, and that sits here under the intake manifold. And the idle control valve acts in conjunction with the DME, the computer, to stabilize idle speed at various conditions. And again, it's bypassing the butterfly valve in the throttle body because it's connected to the J-boot, and so the motor can turn the valve in the system and allow air to pass through into the intake to make it more lean or more rich, to adjust the air and make sure the idle is stabilized when the car is running. Here's a closer look at the smaller vacuum lines connected to the throttle body right in front of the intake manifold here, so one on the left and one on the right, and they essentially make a loop for the fuel vapor management system, with the exception of this T connector that passes over to the fuel system. So this one comes out and down and connects to control valve number 2 for fuel vapor management, and the other side goes under to the thermo vacuum valve, and that is a temperature controlled switch that will allow vacuum to pass through once it reaches operating temperature. And then there's an outlet line that comes from that one, and that one connects to control valve number 1. Control valve number 1 has the vapor lines, these gray or white braided lines, one to the fuel tank and one to the charcoal canister tucked behind the fender here. And so that system will activate and begin to manage the fuel vapors once the engine has reached the proper temperature. So the one split in the system is at this T connector, and that goes up underneath to the fuel pressure damper and the fuel pressure regulator. So let's take a look at those. Up here at the fuel rail is where that line connects to another T connector, and one side goes to the regulator and another side to the damper. And these items are here to stabilize the fuel rail. As engine load increases, so does the fuel demand and the manifold pressure. So imagine that the engine speed is increasing from idle, the fuel injectors will be firing more frequently, and that's going to require more fuel. But the pressure at the injector outlet should be constant, ideally a 1-to-1 ratio of manifold pressure to fuel pressure, and that's the job of the fuel pressure regulator. So inside the regulator is a diaphragm in the center here, and this side has a spring-loaded system connected to the vacuum, and the other side has a valve that controls the fuel pressure. And those two systems work together to balance that load and maintain the 1-to-1 pressure ratio on the system. So if the vacuum line to the fuel pressure regulator is cracked and leaking, this side won't have the power it needs and pressure won't be optimized at the rail, and that will result in things like rough idle, stumbling, sputtering, and no start conditions and things of that nature. The damper works in a similar fashion in terms of its functionality, but it's of a lesser importance than the regulator. It's basically dampening the pulsations of the injectors as they're firing. The little plunger will create some vibrations or some waves in the fuel and the liquid in the system, and this helps kind of smooth it out a little bit. The system can run without a damper, but it does make things a little bit smoother, and it kind of functions from a vacuum perspective in the same way. That brings us to the HVAC system components and its vacuum supply, which on this car comes from the fuel pressure regulator to this T connector through a check valve and yet another T connector. On the left side, that passes through the firewall to the vacuum reservoir, and if we follow that below, I have some red lines to signify heating components, and that one here is a supply line that goes through the firewall to the cabin, where it powers the solenoid valves and the ventilation flaps for the system, and the one that's positioned lower routes over to the heater control valve and will actuate that system to allow hot water to pass into the heat exchanger. On the earlier cars, the vacuum reservoir was located on this side of the firewall. It's green for the very early ones and then black, and for the later cars it was positioned back here by the battery. And the vacuum reservoir supplies a store of power for the car's HVAC system. That way, if you're heavy on the accelerator and vacuum supply is limited, there's enough reserve power there to operate the HVAC system and maintain your cabin temperatures as you've set through the climate controls. And the check valve acts to maintain that system pressure to the reservoir. And again, on this car, that check valve is in line with the regulator, and on some of the other cars that have the T-shaped connector on the brake booster, a line will come out from there, and then the check valve will be positioned here, and then that will route back to give supply power to that system here. So that completes the overview of the main components. In order to get a closer look, we'll need to remove the fuel rail and the intake manifold, and then we can see a little bit more of how things are routed around. In order to access the vacuum lines beneath the intake manifold will need to be removed from the engine, and that means that the fuel rail and injectors will need to be removed as well. To do so, there are a couple different options. One is to disconnect and remove the entire assembly with the rail and the injectors attached, and there are some spring clips, some retaining clips at the top of each injector site that hold it to the rail, and so we would just unbolt it and disconnect the electrical connectors and the vacuum lines, and then you can pull the entire rail and the injectors away from the system and set it off to the side, and that way we're not dumping a bunch of gas and messing with the tops of the O-rings and different things on the system. However, if you don't have your retaining clips in place, or if you're servicing the injectors or other items here, you can go ahead and pull the rail away from the injectors, and when you do so, it's going to start dumping fuel from each of those injector connections, and so you want to stuff a whole bunch of catch rags underneath to catch some of that gas. With the rail up and out of the way, each injector will be left there individually in the intake manifold, and you can twist and wiggle those out separately and set those aside in a safe location. It's best to keep them in an airtight container, preferably indoors where it's climate controlled, so that moisture and things aren't getting inside and clogging up the injectors, and that way you won't have to have them cleaned and serviced. You can just reinstall them if they're going to be out for a period of days. In this case, everything is fine on the fuel rail system, so I'm going to leave the injectors attached and remove it and set it off to the side, and then we'll begin removing the intake manifold. So just use a little flathead screwdriver to disconnect the spring clips on each of the electrical connectors and remove the plastic cover. Disconnect the vacuum lines on the damper and the regulator, and then unbolt the 4 10mm bolt connections, and then everything can be pulled off and positioned out of the way. Here's a closer look at the underside of the fuel rail with the injectors attached. You can see the spring clips a little bit closer and the injector needles. So I'm going to pick this up and set it off to the side here, and I'll probably cover these with some plastic bags just to make sure that no dust is getting into the outlet site, and make sure that when I set it down, I'm not setting it on those needles as well. With the fuel rail out of the way, I can now remove the intake manifold. Before doing so, there are a number of connection points that need to be disconnected. There's one on the air oil separator tube, 10mm bolt for the oil dipstick tube, vacuum line from the brake booster, the throttle cable, 2 vacuum lines on the throttle body, a electrical connector for the throttle position switch. Disconnect the J-boot, 10mm bolt on the top of the cruise control cable, another 10mm bolt for the bracket for the speed and reference sensors, and then disconnect this vacuum line so this can snake in between here. And then we've got 8 6mm hex heads that need to come off, and 1 13mm support bolt underneath. And then the intake manifold can be tilted up a little bit, and there's a final connection vacuum line for the outlet on the idle control valve. Get a screwdriver in there and undo the hose clamp, and then the whole unit can be removed. Here's a look at all the vacuum lines now that the intake manifold has been removed. And from a distance, it kind of looks like a tangled mess of hoses and wires. So let's go ahead and match up the lines as we looked at them the first time around. So again, for the big stuff, here is that line for the air oil separator. Connects to the top of the filter and then around to the top of the intake. Back to the J-boot. And there's a line that we couldn't see before that goes up and under to control valve number 2 for the fuel vapor management. There's that brake booster line that comes down and is just sitting here to the lower intake. And then the idle control valve from the bottom of the J-boot over and across to here and then out to the bottom of the intake. This is a line that I did replace on this car that was split when I first got it. And I've also replaced all the little lines. And you can see these look different from the factory lines. This is a silicone kit from Lindsay Racing. So let's take a look at those little lines. One on the left, one on the right, that go to the throttle body. And they do the loop for fuel vapor management like we talked about. So the one on the left just goes over to the thermo vacuum valve at the top of the water neck and over and around to control valve number 1. And the side that was on the right goes to control valve number 2. And there's the T connector that goes under over to the fuel management system. One side to the fuel pressure regulator, the other side to the damper, and from the regulator to the check valve and the HVAC system components that we looked at before. Now that we've had a look at where everything routes, let's talk a little bit about the differences between the early and the late cars. So for 1988 and 1989, the Venturi was deleted from this vacuum setup and an idle control valve was added in place of the auxiliary air valve and the supplementary air valve. So that's the primary difference when it comes to early and late. On these larger line connections, the brake booster line would come down on an early car and connect up to the Venturi, and the Venturi would go to the intake manifold, and the Venturi would then split and come around to this blocked off connection here, which is for the idle control valve on the later cars and the auxiliary air valve on the earlier ones. And then it would come down the same way and connect up to the bottom of the intake. However, on the earlier cars, instead of stopping there, it would come back around to the supplementary air valve and then loop back to the front of the Venturi, which connected back up to this blocked off connection. So that was a little loop on the earlier cars. And then up here, instead of having an air oil separator connection at the top, that would essentially just stop at the top of the filter for the air oil separator for the larger systems. For the smaller systems, the lines here are basically the same in terms of their routing positions, with the exception of the difference in the connection point on the brake booster. There's a T valve instead of the L, and the check valve for the HVAC system came out of that line and sits here, versus the late is over here. Otherwise, they route the same to valve number 2 and valve number 1, and the thermo switch and the T connection up and under to the damper and the regulator. So just a few differences between the early and the late. With all the vacuum lines exposed, it's a good time to go ahead and check for damage or potential leak sources. So check each of the connection points. Are they still firmly connected, or are they loose and falling off? And trace all of the lines end to end, top to bottom, twist them, bend them, and determine if they're hard and brittle or if they're still flexible and usable. Check for cracks. Some of the larger lines are less prone to cracking, with the exception of this one leading to the idle control valve. It's a little bit thinner rubber and that one can crack. And if you find a problem point, you can replace individual parts on the factory setup. So these connectors are still available, the elbow connectors and the T or the Y connectors. These are about $10 and these are about $15, and there is about 16 of them here on the system. And so if you want to do the whole thing, it can add up and get pretty expensive. With the line and everything, you're going to be approaching about $200. What happens on these is they get hard on these ends and they don't hold their connection, like this falls right apart. So not a very tight connection on these because they're so aged and brittle. So most people just go ahead and replace everything, and to save costs, you can switch over to this aftermarket silicone line, and some kits available by Lindsay Racing. They're about $40, and it comes with 20 feet vacuum line, a color of your choosing, whether that be black, red, or blue, and it comes with 3 of the T connectors. For this setup, I went ahead and customized it because I needed additional parts anyway. So the 88 and 89 has a 4th T connector, so I ordered a 4th one of those, and then I did 18 feet of the black hose and 2 feet of the red hose for the heating components. And I also picked up a bulkhead connector for the pass-through to the vacuum reservoir through the firewall. So go ahead and pick which option is best for you. But if you decide to replace, whether it be factory or aftermarket, it's quite easy to do. So let's go ahead and take a look at how you would do that. Before you start replacing any of the vacuum lines on the system, it's a good idea to go ahead and double check the accuracy of the routing. Could be perfectly fine the way it's set up, but there's no telling who's been in here and what's been swapped around over the years. So good practice just to double check before you start, and hopefully the description in the video assists with that. Otherwise, there are some diagrams that you can track down online. There's not a ton of stuff for the 88 and the 89 models, but you can also use the factory hose routing diagram on the passenger side wheel arch here. And this layout of this diagram isn't spatially set up quite the same way as the engine, so it can be a little bit confusing, but if you stare at it for about 30 minutes, you can track down some of these parts. So here is control valve number 1 and control valve number 2 for fuel vapor management. And so the line comes out of the throttle body to the thermo switch and then back around to valve number 1. These little humps here indicate that the line's passing over, it's not connected to those lines. And then valve number 2 to the T connector to the other throttle body connection. And then that T splits off to the T for the fuel pressure regulator and the fuel pressure damper located here. It also shows the carbon canister or the charcoal canister and its T connection located behind the driver's side fender. And you have the idle control valve here from the manifold back to the J-boot. That's set up there. And it shows the distributor, I guess, for reference. If you flip the diagram, I guess that makes a little bit of sense, but for whatever reason it doesn't show the brake booster. But here's the line to the brake booster, and the diagram is also missing the lines to the check valve for the heating system and the air oil separator. Those components aren't on here, but most of the little lines you can track down, and it is useful in that manner to just confirm everything is set up. And once you've done that, you can go ahead and begin replacing some lines. As you begin to replace the vacuum lines on the system, it's a good idea to start on one side and kind of work your way over, and that way you can leave most of the items in place while you're swapping out parts, and it's less confusing that way. So go ahead and pick one of the valves and remove the old connector, swap it out with a new one if you're doing the factory setup, and then run some of the line following that same pathway in the engine bay and cut it to length, and just move on from each connection to each connection point until everything is replaced. When it comes to using an aftermarket line, there's a couple things you can do. So you can leave the existing factory line in place on the system and just kind of clip some of the silicone line to that connection point with a clamp or with some tape, and then route it around that same pathway in the engine bay so that you have the appropriate length, and then you can cut it to length once you get to your end point, and then remove the old factory line and plug in the new line. And you can also just remove a single line from the components in the engine bay and kind of lay it out on the floor and line up the silicone line that way so that you have the appropriate length, and cut it there in place, and then go ahead and return to the engine bay and install the new line. and just keep working your way through the system, and you can cut different lines halfway through to install T-connectors, and you'll have a little bit of extra line as well. If you make a mistake, you can just scrap it and install some different one at the appropriate length and work your way towards the left and over to the back to replace all the heating lines and get everything set up. And if you've confirmed that everything is correctly routed and installed firmly at each connection, you can go ahead and start thinking about reinstalling some of the components on the top of the engine here. It's also a good idea to inspect the O-rings on the air oil separator and see if there's any oil seeping out of the upper or lower connection point down the engine block. And if there is, you can replace those while the manifold is off. And along with the idle control valve, you can pull the lines and inspect for any buildup of debris or residue that may be clogging the valve. And you can test the valve by removing the electrical connector and attaching a battery to the center pin, and then the other terminal on the battery you can alternate between the upper and lower pins on that connection point to open and close the valve, and it should snap pretty quickly open and close as you're doing that. And if it doesn't, the valve is either stuck or seized or damaged, and you can spray some carb cleaner through the opening in the valve to see if you can clean it out and free it up. Otherwise, if it's not working, it's time to replace that valve. So once everything is set up and properly routed, you can go ahead and reinstall the intake manifold and the fuel rail and test the car's operation. The intake manifold is reinstalled in the reverse order, so go ahead and lower it into position and reconnect the line at the bottom from the idle control valve and get that secured. Line up the top and resecure the J-boot. Apply some new seals across the top. The lettering on the seals will go face up with the exception of cylinder number 1 where it's flipped and the lettering goes face down. You can then reconnect all of the various components to the intake manifold, the throttle position switch, the throttle cable, the connection for the air oil separator, the oil dipstick tube, and the bracket for the sensors in the back, and install the bolts. The 6mm bolts are torqued to 15 foot-pounds, as well as the 13mm support bolt underneath. When installing the fuel rail and injectors, the O-rings will get a light coat of automatic transmission fluid, push the injectors straight into the holes in the manifold, and route the spark plug cables through the front in between the rail and the high pressure fuel line. Install the 10mm bolts front and rear, reconnect the electrical connectors to each injector, tighten everything down, and install the vacuum lines to the damper and the regulator, and then reinstallation will be complete. With everything reinstalled, you can go ahead and start the engine and check for normal operation, assess the repair, and confirm if the vacuum leaks have been resolved.